And we're just going to start with the intro to the lesson. So we're getting into polynomials and how to divide them. Yesterday we looked at how to classify them by degree, by number of terms, also by the coefficients out front. And now that we understand how polynomials look and how they, I guess, can be ordered, we're going to get into division. So I took you guys back to grade 6, now I'm going to take you back to grade 10 again. We have a polynomial, 15x cubed minus 10x squared plus 5x, and we're dividing by 5x. What you first want to do when you're dividing a polynomial is check, can you divide each term individually by 5x? Okay, and we're going to see that we can. So 15x cubed can be divided by 5x, negative 10x squared can be divided by 5x, and our last term, 5x, can also be divided by 5x. So if that's possible, then we can just divide each term by the divisor. Okay, 15x cubed divided by 5x. Let's start with the coefficients. 15 divided by 5? 3. X cubed divided by x?
X squared.
X squared. So our first term, we are left with 3x squared. Second term, negative 10 divided by 5?
2.
Negative 2. And x squared divided by x? X. Lastly, 5x divided by 5x, cancel out. Am I done? No, don't forget to put the plus 1. Okay, this is a really common mistake. I see students see that they're canceled out, so they assume, oh, done. But remember, anything divided by itself is 1. Okay, if we talk about the solution to our question here, the dividend is going to be the polynomial that we start with. Okay, that's the polynomial on top. The divisor is what we're dividing by. And the quotient is the result of our division statement. It's what we ended up with. And if we have a remainder, that's going to be what's left over with. So, for example, if we were to look at 20 divided by 3. Okay, so 20 divided by 3, can it divide evenly? How many times does 3 go into 20 though, evenly? 6 times. Okay, so the dividend, 20, divided by 3, which is our divisor, leaves us with a quotient of 6. Now if I go 6 times 3, I get 18, right? So what's your remainder? 2. So if I look at this, I have 20 divided by 3 equals 6, but I still have 2 divided by 3 left. Or we could write it as 20 is equal to 3 times 6 plus 2, which was our remainder. Joe's, what you thinking?
I thought it was 21 afterwards.
That's 3 times 7.
Yeah, I know.
So how we record our answer is in 2 forms. Okay, the first form would be the dividend is equal to the divisor times the quotient plus the remainder. That's what we see here. Okay, 20 equals our divisor 3 times our quotient 6 plus our remainder. Or the second form would be that our dividend, which is 20, divided by 3, our divisor, equals our quotient 6 plus our remainder over our divisor. And that's what we see here. In the case of this lesson though, we're going to be dealing with polynomials. So instead of using the term dividend, so the number or the polynomial that we start with, we're going to be using the term polynomial. And that leads us into 2 forms in which we would answer our question. Okay, so we would have the polynomial, right here, is equal to the divisor times the quotient plus the remainder. And in short, we have P equals dq plus r. Dairy Queen's pretty good. That's how I remember that one. Okay, the next one is polynomial divided by our divisor equals the quotient plus the remainder divided by our divisor. Or P over D equals Q plus R over D. So we have a student who used long division, and after she went through the process of dividing 739 divided by 35, she figured out she had a quotient of 21 and a remainder of 4. Okay, so let's just label what we know. This is our original polynomial. Even though it's a dividend, we'll just call it polynomial, so you get used to the form. Okay, this was our divisor, 35 on the side. The end result is your quotient, and the number left over is your remainder. So this student answered her division statement in two forms. The first one is the polynomial equals the divisor multiplied by the quotient plus the remainder. 739 is equal to 35 times 21 plus 4. Or she could answer it as the polynomial divided by the divisor, so 739 divided by 35 equals the quotient, 21, plus the remainder, which still needs to be divided by 35. Okay, but I meant to put P over D equals Q plus our remainder over our divisor. So those are the two forms in which we'll be answering our questions. Now you guys probably answered this already, 5,773 divided by 25. So hopefully you can help me out with this. Can 25 go into 5? No, so let's put a 0 up top. But can 25 go into 57? Twice? So dad divided, now mom's going to multiply. 25 times 2 is 50. What does sister do? Subtract. So 57 minus 50 is 7. Brother brings it down. Now we figure out how many times does 25 go into 77? 3 times. Okay, very good. So we ended up with 75. And then we subtract. Okay, so we get 2. Brother brings down, and we get 23. How many times does 25 go into 23? 0 times. So our remainder is 23. Our quotient was 230. Okay, our divisor was 25, and our original polynomial or dividend was 5,773. So if we were to answer in these two forms, we would have our polynomial. So for P equals dq plus r, our polynomial was 5,773. Our divisor was 25, our quotient was 230, and our remainder was 23. How do you know if your answer was correct? What can you do on the right-hand side? Multiply. You expand it and check. When you multiply and add, does it equal 5,773? If it does, you know you did your job. Okay, the other form is writing the polynomial. Use this pen to work. Divided by your divisor equals your quotient plus your remainder over your divisor. So writing in that form, we have 5,773 divided by 25 gives us a quotient of 230 plus the remainder 23 over our divisor 25. And those are the two forms. How did you guys do, by the way? Aced it?
Yeah.
You did the decimal as well? Okay, in grade 6 we would look at the decimal, but in this case, it's okay that you did that. I'm just saying maybe don't get in the habit for grade 12, because as soon as we get to the polynomials, we won't need to take a decimal. Okay, so that's okay if you went a bit further. Okay, but if we're writing in the form with a remainder, just make sure you leave your R as R. Okay? So if you just went a bit further than I wrote, he's more advanced than us. Now, to get to the good stuff. So our first question is we're going to divide x squared plus 3x plus 18 divided by x. So first thing you need to do is take the division statement and write it so that the polynomial is underneath the division bar, and we have our divisor on the side. So if you want, you can label that right away. This is your polynomial. This is your divisor. So although it looks complicated because there's now variables, the steps are just the same. Dad divides, so we've got to figure out how many times does x go into x squared? Or what would I need to multiply by x to get x squared? X. Good, so then I put an x above the x placeholder. And I multiply back. X times x is x squared. What did we do after we multiply?
Break down.
Sister subtracts. So we subtract and we get 0, then brother brings it down. So dad, mom, sister, brother. Okay, so we get plus 3x. And then we start the process all over. So dad divides. 3x divided by x, or x times what gives us 3x? 3. Good, so we put the 3 up top, don't forget the plus 3. And then mom multiplies, so we multiply 3 times x. And we get 3x. What does sister do? Subtract. So notice that this first term always cancels out, and then we bring down. Okay, is there anything we can multiply x by to get 18? No, so we stop. This is our remainder. Okay, what's this up top? X plus 3. Quotient. So if I'm asked to answer in the form polynomial equals divisor times quotient plus our remainder, so P equals DQ plus R, I rewrite my polynomial x squared plus 3x plus 18. That will equal my divisor, x, multiplied by x plus 3, plus my remainder, 18. How do you know if you did it correct? You expand. So if I were to expand this, or you could sub in a value for x too, just to make sure left-hand side equals right-hand side. But let's just multiply this through. I get x squared plus 3x plus 18. Is that what you started with? Yes.
Yeah.
Okay, so you can always check by expanding, or you could sub in a value for x. So say you said x equals 1. Plug that into this side, plug x equals 1 into that side. If the left-hand side equals right-hand side, you know you did it right. Alright, moving on. We have x cubed minus 5x plus 6 divided by x. Now one thing that's really important is you need to have a placeholder for all the powers of x. So we wrote underneath the division bar here, x cubed plus 0x squared. Notice how there's no x squared? So what I'm going to do is I'm just going to write, I'll erase this. You need to put that there's 0x squared, and that will be a placeholder. Because in our answer, we're going to need an x squared. So you have to have an x squared in your original dividend. So let's pretend they didn't show us any of the work here. We need to first start with dad. How many times what do we have to multiply by x to get x cubed? X squared. So we write that up top. Then we multiply, mom multiplies, so x squared times x gives me x cubed. Then sister subtracts. X cubed minus x cubed cancels out. Then we bring it down. We're bringing down 0x squared. What do I need to multiply x by to get 0x squared? 0x, or 0. Okay, but because we are talking about x times x to get x squared, we would multiply by 0x. Okay, and then I just multiply that through. 0x times x is 0x squared. Sister subtracts, and we get 0. That cancels out, and we bring down the negative 5x. So x times what gives me negative 5x? Negative 5, so put that up top in your quotient. And now mom multiplies. Negative 5 times x is negative 5x. What does sister do? Subtract. So these cancel out. We get 0. Brother will bring it down, and we get a positive 6. Can we multiply x by anything to get 6?
Nope.
So we stop. That's our remainder. That's our quotient. We started with the polynomial divided by our divisor. So if you were to answer in the form P equals dq plus r, our original polynomial was x cubed minus 5x plus 6. That will equal our divisor x times our quotient x squared minus 5 plus our remainder 6. Now some students asked in your final statement, do you have to show that there's 0x squares? No, you don't. Okay. And you have to show that there's 0 x's? No, you don't. Now this next question is a little bit more challenging. It's actually the same steps, but there's just one thing that you need to pay attention to. So this time we're dividing a polynomial by a binomial. So it's not as simple as looking at it and be like, oh, x times what gives me x cubed? Here I have x plus 2 on the side. But it's actually the same thing. You first look at just the variable in the binomial, and you ask yourself, x times what gives you 2x squared? 2x. Then you have to multiply this 2x through both terms of the divisor. Okay, so that's the only extra step. So 2x times x gives me 2x squared. Good, those are the same. And 2x times 2 is 4x. So after I multiply, sister subtracts. These first two terms cancel out. Negative x minus 4x is negative 5x. After sister subtracts, we bring it down. And we start the process all over again. So dad's going to divide. X times what gives me negative 5x?
Negative 5.
Negative 5, good. So negative 5 times x is negative 5x. Okay, don't forget though, you also multiply by the second term in the divisor. If I'm going too fast, just let me know, I can rewind.
It's good.
You're good? Okay. Now negative 5 times 2 is negative 10. Sister subtracts. Negative 5x plus 5x, that cancels out. Negative 18 minus a negative 10, that's like negative 18 plus 10. So we get negative 8. And now we figured out what our remainder is, our quotient, and we knew our polynomial and our divisor. So we just plug it into the form, P equals dq plus r. Our original polynomial, P, was x squared minus x minus 18. What was our divisor?
X plus 2.
X plus 2. And I'm just going to finish that I'll answer, okay? Our quotient was 2x minus 5, and our remainder was minus 8. Yeah, Jake?
So everything we put at the top, we have to multiply by the divisor.
You got it. So let's just go back to the first step. X times what gives you 2x squared? 2x. And then you have to multiply that 2x by both terms in the divisor. 2x times x is 2x squared. 2x times 2 is 4x. So whenever you have a binomial as your divisor, you need to multiply whatever you figured out in your quotient by both terms in the divisor. Okay. There's a little video if you guys want to check it out. I've already added it to Moodle, but if you want a little bit more help, it's right there in your workbook. I actually added 3 videos to Moodle, so if you need a little more help on this, extra resources are already posted. Okay, take a look at your new expression. We have y cubed minus 6y plus 20 divided by y minus 3. What would we call this in this statement? Our polynomial, p. Good. Okay, and when we're dividing by something, what do we call that? Divisor. So that's our d. So the polynomial always goes underneath the bar, but what do I have to remember with the polynomial like this? It's missing something. Pardon?
Put a placeholder for y squared.
Perfect. We need a placeholder for y squared. So you write y cubed plus 0y squared minus 6y plus 20. Okay, don't forget the placeholder. Okay, and then the divisor you write on the side, we have y minus 3. Jane, do you have a question?
No.
Some people might want to hear.
And no, I'm just confused. Like, I don't know what the placeholder is.
So the placeholder is important because at some point, for example, when we look at y times what gives us y cubed, what is the answer? Y times what gives us y cubed?
Y squared.
Y squared. So when we multiply it through, we'll end up with a y squared, because y squared times 3 is 3y squared, right? So we're going to need somewhere that we can put that y squared. So you always need a placeholder so that it has somewhere to go at the end. Okay? In the last example, it worked out that there was actually 0 x squares, I believe, so it didn't seem like it made much sense. But in this case, we will need that placeholder. Okay, so let's start from the beginning. Remember, we're looking at the y, and we're asking y times what will give me y cubed? Y squared. So we put that above the y squared. And then we have to multiply the y squared by both terms in the divisor. So y squared times y. Y cubed. Y squared times negative 3. Awesome. Okay, and the goal is that you want that first term to always cancel out. So when we subtract y cubed minus y cubed, that cancels out. And you can put the 0 or you can just leave it blank. It's up to you. Then we go 0 minus negative 3y squared. That's basically like adding, so we have positive 3y squared. And we start the process all over again. So, y multiplied by what will give you 3y squared? 3y, perfect.
Wait, so why doesn't the negative 6 go down after that one?
Sorry, it does. Thank you. Yeah, after we subtract, we bring it down. Good, Josie's paying attention. So, we figured out y times 3y gives me 3y squared. So just expanding that, 3y times y, 3y squared. And 3y times negative 3 gives me negative 9y. And that's why we needed to bring down that negative 6y. So we needed something to subtract with the negative 9y. Okay, so we brought that down. We multiplied through. Now we're going to subtract. So 3y squared minus 3y squared, that cancels out. That was our goal. Now negative 6y minus negative 9y. It's basically like adding, right? So negative 6y plus 9y is 3y. After we subtract, we bring down the 20. And we start over again. Y times what gives me 3y? 3. So we put the 3 up top. And now we have to multiply that 3 through both terms in the divisor. 3 times y, 3y. 3 times negative 3, negative 9. What does sister do? Subtract. So when I subtract, the 3y's cancel out. 20 minus negative 9, it's really like 20 plus 9. So we end up with 29. Are there any more terms to bring down?
No.
So we can stop. As well as you can't multiply y times anything to get 29. So this is our remainder. This is our quotient. This is our polynomial. This was our divisor. This time they want us to answer in the form p over d equals q plus r over d. So we have our polynomial that we started with, y cubed minus 6y plus 20, divided by our divisor, y minus 3. That equals our quotient, y squared plus 3y plus 3. And then we have to add it with our remainder, 29 over our divisor, y minus 2. Yeah.
So you don't have to write the 0y squared ever on the left side?
On your final answer, you don't have to put that you have 0 of something. So this is simplified. When you're actually doing the division, you need the placeholder.
Okay.
Okay. So to clarify this division algorithm, I'm just going to give a little example to make it easier to understand. So say I went 15 and I had to divide by 3. What would you get? 5. And would you guys agree that 15 is equal to 3 times 5 with a remainder of 0? So would you also agree that 3 and 5 would be factors of 15? Okay. If you have a remainder of 0, then your divisor and your quotient are considered factors. What if I had, like at the beginning we divided 20 divided by 3, and I ended up with 6 plus a remainder still? Okay. Or if I wrote that as 20 equals 3 times 6 plus a remainder. Would you say that 3 and 6 are exact factors? No, because there's a remainder of 2. So we can say that our divisor 3, in this case, if we go back to 15 divided by 3 equals 5, our divisor 3 and our quotient 5, they're considered factors if the remainder is 0. In this example, we cannot say that 3 and 6 are factors because we have a remainder. So that summarizes this statement right here. Okay, that's very important. If your remainder, r, is equal to 0, your divisor and your quotient are both factors of the original polynomial. And if r doesn't equal 0, they're not factors. That's the next statement. There's a few other things to know about when you're dividing. So the degree of the divisor, it must be greater than the degree of, or must not be, greater than the degree of the polynomial. So we're never going to multiply an x cubed, we're never going to go like an x cubed divided by an x to the power of 5. The divisor never has a greater degree. Never, never. Okay, and same thing with the remainder. The remainder's degree has to be less than what you started with. So the most important statement I hope you guys got out of this though is that if your remainder is 0, then your divisor and your quotient, they're considered factors. So we just have a question here that's going to test your knowledge on that statement.
Senior class change.
So we have a polynomial and we have to divide by 2x minus 1. So here's our polynomial, here's our divisor. So if I were to write that in a division statement, part A kind of gives this away, but what you need to do is rewrite that polynomial so that it's in descending order. So we're going to start with 6x to the power 4 plus 5x3. Do I have any x squares? So what do I need to put? Placeholder. So 0x squared. I have negative 4x and positive 1. And before you go any further, I would just check that you have all your signs correct. Check that you got all the placeholders. Did we do okay? We included everything. Now we're going to write our divisor on the side, 2x minus 1. And we can start multiplying, which is kind of like dividing. Okay, so 2x times what will give me 6x to the power of 4. Let's just start with the 2 and the 6. 2 times what gives me 6? 3. Okay. X times what gives me x to the power of 4? X cubed. So I have 3x cubed. What do I do with that 3x cubed?
Times it by 2.
Good. You multiply it by both terms in the divisor. So 3x cubed times 2x gives me 6x to the power of 4. And 3x cubed times negative 1 gives me negative 3x cubed. Next up, subtract. Okay, first terms cancel out. 5x cubed plus 3x cubed, I get 8x cubed. Just remember, it's 5x cubed minus a negative 3x cubed, so that's why it's adding. And we bring down this lovely 0x squared. And we start over. Xander, 2x times what gives me 8x cubed? Awesome. 4x squared. And then Chris, what do I do with that 4x squared?
By 2x and by negative 1.
Good. So 4x squared times 2x is 8x cubed. And 4x squared times negative 1 is negative 4x squared. Then we subtract. First term cancels out. 0 minus negative 4 gives us positive 4x squared. After we subtract, we bring down that next term, negative 4x. And we start over again. Joe's 2x times what will give me 4x squared?
2x.
2x, good. And then if we multiply 2x by 2x, we get 4x squared. If I multiply 2x times negative 1, I get negative 2x. Subtract. First term cancels out. Negative 4x plus 2x. Negative 2x. Bring down the plus 1. And last stage here. 2x times what gives me negative 2x?
Negative 1.
Negative 1. So put that up top. We multiply that negative 1 by 2x. We get negative 2x. And negative 1 times negative 1 is positive 1. What happens when you subtract? 0. So our remainder is 0. Our quotient is up top. Polynomial here. And our divisor on the side. So if I were to rewrite this in the form P equals dq plus r, we'd get 6x to the power of 4 plus 5x cubed minus 4x plus 1 equals your divisor, 2x minus 1, times your quotient, 3x cubed plus 4x squared plus 2x minus 1. What's your remainder?
0.
0. Do I need to put the plus 0? No. So if I take that 0 away, what can we say about the divisor and the quotient? They're factors. So in part C, if they're asking you, is 2x minus 1 a factor? Yes, because the remainder equals 0. In the next example, we have our polynomial divided by 2x minus 3 gives you quotient x squared plus 4, remainder negative 2. Is 2x minus 3 a factor?
No,
Why?
it is a negative 2.
Good. If you have a remainder that's not 0, then this cannot be a factor, just like that can't be a factor. So let's actually answer this question. Okay, so first of all, state the divisor, the quotient, and the remainder. I think we already did that. But I'll do it again. Okay, so our divisor is on the side. It's 2x minus 3. Our quotient is on top of the division bar, so x squared plus 4. And our remainder, negative 2. So if I have polynomial is equal to our divisor times our quotient plus our remainder, given that we know our divisor, quotient, and our remainder, would you guys be able to come up with the polynomial? So let's plug in what we know. Our divisor was 2x minus 3. Our quotient was x squared plus 4. And our remainder is negative 2. What do I need to do to find that polynomial?
Just distribute.
Yeah, distribute or expand. So if we do that, we get 2x times x squared is 2x cubed plus 8x minus 3x squared minus 12 and then minus 2 for our remainder. And if we clean things up and put them in descending order, you get 2x cubed minus 3x squared plus 8x minus 14. Okay, that's what P equals. Sorry, both my markers are running out. So how do you guys feel about long division in grade 6? I think you guys did awesome.